equations of linear motion. Rotational motion. V u plus at omega u omega naught alpha t. This is first equation of rotational motion. S ut plus half at square theta u omega t half a alpha t square x naught plus ut plus half a t square. तो theta naught plus omega t half alpha t square. Same v square u square 2as v square u square 2a as अल्फा थीटा. कैसे लिखे? इस जैसा ये एनालोगस टू दिस. ये लीनियर मोशन, ये रोटेशनल. नाउ वी विल ड्राइव दीज इक्वेशंस. डिराइव ओमेगा नॉट अल्फा टी where omega naught initial angular velocity, omega final angular velocity in time t, alpha angular acceleration. How this was derived? We have taken a dv by dt. So we know instead of a alpha is what? Rate change of angular speed. Alpha dt d omega. Integrating it within limits. Alpha constant outside dt d omega limits. There will be two values of omega, there will be two values of. In beginning, last time, lower, higher limit. In beginning, omega was omega naught. After time t, it was omega. Alpha dt t. What is this dt? It is t0 dt. Integration at 1 to power, divide by same power. So d omega, it is omega naught omega, it is 0 t. T minus 0, omega minus omega naught. So it is omega. Take this to this side, omega naught alpha t derived चलिए देखते हैं डिराइव थीटा थीटा नॉट टी हाफ अल्फा टी स्क्वायर सॉल्यूशन चेक दिस डिस्टेंस निकालना था v dx बाई dt लिया था हमने यहाँ डिस्टेंस यहाँ पे डायरेक्ट एंगुलर डिस्टेंस डिस्प्लेसमेंट निकालना है we know what we know omega d theta by dt omega naught alpha t d theta by dt we know this just done omega naught dt alpha t dt take t this side d theta integrating it within limits omega naught outside dt alpha outside t dt d theta within limits there will be two times theta 0 angular displacement in 0 time theta displacement in time t 2 times 0 t two angles initial final initial angular displacement final so omega naught integrate t 0 t add 1 to power divide by same power 0 t this is what theta theta naught theta omega naught t minus 0 it is half alpha value of t is t square is there value of t 0 square is there it is theta minus theta naught omega naught t half alpha t square theta minus theta naught or theta take theta naught to this side theta naught plus omega naught t plus half alpha t square what derived now this one is left means we have to derive this derive two alpha theta Again a question. Now directly angular displacement नहीं निकालनी है यहाँ. So take, we know alpha, it is d omega by dt. But displacement is there, so what? Multiply by d theta, divide by d theta, so that equation not changes. Alpha d omega d theta, ये पहले लिखा, dt. Now d theta by dt is what? Omega. Alpha d omega d theta into omega, or alpha d theta is omega d omega. Now this equation is ready for integration. Integrating it within limits. Alpha d theta, limit of theta. Theta is variable here, so it is 0. Only one angle is given, theta. So in 0 time the angle will be 0, and in t time this will be what? Theta. Omega d omega. When displacement was 0, the initial angular velocity will be this, final will be this. So this is alpha. It is what? Theta. 0 to theta. It is what? Omega square by 2. Omega naught omega. Alpha limits theta minus 0. This is what? Omega square. Value of omega is omega. Minus, square is there, so square. Value of omega is this. Square is there, so square. Or it is 2 alpha theta is omega square, omega naught square. Hence what? Derived. A numerical. Angular speed of wheel increased from RPM to RPM, revolution per minute, in 16 seconds. Number 1, what is angular acceleration? Number 2, number of revolution in given time. a question, a numerical. Angular speed of wheel increases from RPM, frequency है ये, RPM by revolution per minute per second, RPS. It is 20 RPS or hertz. So omega naught, 2 pi nu naught, it is 2 pi into 20 radian per second. Increases from this RPM to this RPM, nu 3120 RPM by 60 RPS, it is what? 52 hertz. Omega 2 pi nu 2 pi 56 watt radian per second. Angular speed is this, from this to this. ये frequency given है, though written is angular speed. This is angular speed. In time is what? 16 second. What? This. Omega naught alpha t. So alpha comes out to be omega minus omega naught by t. Omega 2 pi 56, omega naught 2 pi 20 by 16. 2 pi common, 56 minus 20 by 16. 2 pi common, it was 52. It was 52. (32 by 16). It is 4 pi radian per second square. One answer is there. Second, number of revolution in given time. When 2 pi is angle, revolution is 1. एक चक्कर 2 pi angle में. This means we have to find angle. Now theta. Omega t plus half alpha t square. Omega naught 2 pi 20 t 16 plus half alpha. Alpha was 4 pi t square 256. 640 pi, it is 2 pi. तो it comes out to be 2, 5 pi. This is the angle, radian. Number of revolutions in 2 pi, revolution is 1. In 1 by 2 pi. In this, so pi goes with pi, and it is what? 5, 7, 6. So this is the answer, and this is the answer. Two particles, mass mh, are moving in opposite direction with velocity mh. This is a particle. This is another particle. Mass mh. So L of two particle system is same wherever the point which angular momentum is taken. This is point A. This is point B. This is point C where angular momentum is taken, and this distance, say D. Let this distance be x, then this distance will be d minus x. Let A, B, C are points about which angular momentum is taken. Say this is first particle, this is what? Second particle. They are moving in opposite direction according to question. Let AC is D and AB is X, then BC will be D minus X. Moment about A. एंगुलर मोमेंटम है, तो मोमेंटम अबाउट ए फर्स्ट पार्टिकल, L was RP sin phi. Phi is angle between R and P. So this is R, this is P, R and P. R is what? It was RP. When phi is 90, perpendicular distance. So here, say this is the distance about which, here the distance is 0 for this first particle. So this is 0. Why this R is 0 here? So the total will be 0. Now R P for this particle, R is what? It is D. P, it is mv. So momentum about A is B mv number first. Momentum about B. For this first particle, this is the direction. This is the particle, so this is the direction of rotation. This will be direction. This is V. So it will be what? X, RP, XP, MV. This will be rotation. Now for second particle, D minus X, MV, Y plus about this point B. The rotation is in clockwise. For this the rotation is in clockwise, so both will be added and it comes out to be DMV. Momentum about C. For this, the distance C, here. For this, the distance is R is D, P, MV. For second particle, the distance is 0. So it is 0 and it comes out to be DMV third. Hence what? Proved. What I want to prove? Two particles of mass m each are moving in opposite direction with velocity which are so that L of two particle system is same. At A, it was found same. At B, wherever the point will be taken at C, it was same. Another question. So, angular momentum about any point by a particle moving with constant speed remains constant. Another conceptual problem. This O is any point about which moment is taken, and this is a particle moving with constant speed. This is perpendicular distance. The question is here. the angular momentum remains same. Here, the momentum remains same. Again, so that angular momentum about any point. ये यहाँ P पर P ऑब्जर्वेशन पॉइंट ले लिया हमने. O is any point about which angular momentum is taken. P is observation point. OK is perpendicular distance and it is constant. V is velocity and constant. OP is R. Phi angle as shown. This is R. ये आर यहाँ ऑब्जर्वेशन पॉइंट यहाँ आ गया. फाई विल चेंज, आर विल चेंज. यहाँ है ऑब्जर्वेशन, फाई विल चेंज, आर विल चेंज. दिस विल बी आर, दिस विल बी फाई. बोथ दे चेंजेस फाई एंड आर. Now angular momentum Rp sin phi OK by R. OK by R is sin phi. R OK by sin phi into P mv into sin phi. Sin phi goes with sin phi. So L is OK into M into V. So what? It is constant because OK is constant, M always constant, V velocity constant given. We know this thing. The angular momentum is Rp sin phi. Phi was, when we did angular momentum and this relation, this was angle phi. Now about this point moments are taken. Observation point may be here, may be here, may be here. So this distance remains constant, this distance changes. So R changes, phi changes, and with this we know this thing. L is Rp sin phi. So R चेंज करो इसको। ये राइट एंगल ट्रायंगल है, ऑब्जर्वेशन पॉइंट फिलहाल ये सपोज किया हमने। तो ओके बाई आर इज साइन फाइव, तो आर की वैल्यू रखी है हमने, दैट्स ऑल। ओके बाई साइन फाइव, तो साइन फाइव गोज विद साइन फाइव। ओके कांस्टेंट पी इज व्हाट, एम वी। m constant, mass always constant, velocity given constant, okay is constant, so it is constant, and this we have to answer. Laws of rotational motion. We have already read laws of motion. First law, in absence of external force, a body at rest will remain at rest. Second, f dp by dt. Third, action reaction. We have read laws of motion, already read in previous classes. So laws of rotational motion on basis of same. There was in absence of external force here. In absence of external torque, instead of force, what? Torque. A body at rest will remain at rest, and body in rotational motion will remain in rotational motion with same angular speed. So this is what first law. Second, there was F directly proportional to dp by dt. Here torque dp, तो dl by dt हो जाएगा. Rate change of angular momentum is directly proportional to external torque, that is tau dl by dt. There was f dp by dt. So this third law was forces equal and opposite, torques are equal and opposite. So these are what? Laws of rotational motion. A rope of negligible mass is wound around a cylinder of mass 3 kg and radius 40 centimeter. What is number 1? Angular acceleration if rope is pulled by force (30 Newton). What is linear acceleration? This is a question. This is a cylinder, this is a rope, this is force, this is R, so this is pulled. So this cylinder start rotating, mass 3 kg, R 40 centimeter means 0.4 meter, force 30 Newton. What is angular acceleration? What is linear acceleration? I, it is mr square. I निकाल लिया हमने 0.4 16.48 kilogram meter square. We know torque RL and torque I alpha. This was definition. This we have already done. Torque is I alpha. I is known. F is so. I alpha is RF or alpha RF by I, or alpha R was F I, so it is 40 into 30 by 48. Ten, 12, 4, 10. It is 100 by 4, or alpha is 25 radian per second square. Arc upon radius theta will be R omega A R alpha. This acceleration linear R alpha. R is what? 0.4 alpha 25. It is 100 means 10 meter per second square.